All aboard! It's Friday evening here on the coding train, and I am here ready to create a coding challenge. And today's coding challenge is going to be... never mind all this nonsense. Plinko. So I'm going to attempt to make Plinko using a physics engine known as Matter.js. What is Plinko, you may ask? Good question. I'm not entirely sure. But I think Plinko is a thing where you have a bunch of balls that fall from the top of a two-dimensional, it's a physical thing. You drop the balls at the top, there's all these little things that they bounce into, and they end up somewhere on the bottom. That was a terrible explanation. I should redo this whole video. I'm going to make it, and then you guys can, if you don't know what Plinko is, pause and go try to look it up and then come back, okay? I have a sort of vague idea in my head. Okay, so yes, and I'm being reminded by Alka in the chat to stay hydrated. Now that I've lost half of the people who maybe were going to watch this video, the rest of you, let's go. Okay, so the first thing that I want to do here is, let's, I'm trying to think about this here. There's a lot of pieces to this. Boy, this is gonna be hard. Let's think about this over on the whiteboard for a second. Okay, so how does Plinko work? I can use the whiteboard to explain it. Plinko is a thing where there is a grid of stationary, I would call them like knobs in a way, and I think each row would be offset from the one below it. So it would be something like this. All the way to the bottom. And then the idea is that you would drop things from the top and it would fall right down and bounce here. And ideally, the idea is there would be a 50% chance of it going this way and a 50% chance of going that way. Then it would hit here and there would be a 50% chance of going this way versus 50% going this way. And interestingly enough, if we do this correctly, which I'm sure we won't, because there's no chance, it's me, there's no chance I'm going to do it correctly, we would see a nice normal Gaussian distribution of where they land. Like they would mostly land in the center with a few outliers. Boy, isn't there some like TV show now called The Wall? I should just put like, I could probably create some sort of like clickbait title for this video, but I'm not going to do that. So then the idea, so then they'll fill up in the bottom. We could use this to like, you win a certain amount of money or whatever. So this is the simulation. So what I need is, I need some mechanism for catching everything in different slots. So these would be kind of stationary. In the physics engine, I could probably make these stationary rectangles, if that's a thing. Then these would be, and static is the word I'm looking for, static circle objects that are around, and then I'm going to have dynamic circle objects falling from the top. So I need really three kinds of things. I'm going to call these particles because that's a good name for them. I'm going to call these Plinkos because we're making Plinko. And then this is going to be a bucket. We'll call these buckets to catch the thing. So I need to make three kinds of objects. And so I'm kind of planning this out. I guess I know I'm going to need arrays for all of these things. So let's sort of see how this goes. Let's try making just the particles first. Okay, so what I'm going to do is, oh, the cup is in front again. Sorry, everybody. You don't want to know what's going on here with my multiple camera system craziness. Okay, so what I'm going to do is I'm going to add a JavaScript file, and I'm going to call it particle.js, and I'm going to say function particle. And I'm going to, when I create a particle, the thing falling from the top, I want to create it at an XY location. Now here's the thing, I'm using a physics engine called Matter.js, and I already have in index.html a reference to the Matter.js library. Now I also have a reference to the P5.js library. That's the library I'm using for drawing, and that's the library that I use in just about in many of my videos, almost all of them. But Matter.js is new, and if you want to learn more about Matter.js, I will link to a set of tutorial videos about Matter separately. I'm just going to kind of rapidly go through adding stuff from Matter without maybe explaining everything, but I do have separate tutorial videos. Okay, now I do need to go to the Matter.js website, and I want to Google Matter getting started, maybe wiki. Because I know that this is going to have some of the code that I want on it, like this, for example. So one thing is Matter is a library where all of the objects and functions that you might call from are namespaced. They all start with matter.something, and I'm going to definitely need an engine and a I don't need a renderer, actually, because I'm using P5. An engine, a world, bodies. So this is a way of just sort of aliasing them so I don't have to say matter dot all the time. And so what I need is I want to have an engine. I want to have a world. I want to have a bunch of particles. That's what I'm starting with. Engine, world, and a bunch of particles. Okay, so engine equals matter dot, no, engine dot create, I don't know, world equals engine dot world. What's the chance that that's right? So I need to create an engine, and then I want a reference to the world that that engine creates. It sort of seems unlikely that that's correct. Oh, it is correct. Engine equals engine.create, and the world is, you can see later, engine.world. Okay, great. Now what I want to do is I want to start creating some bodies. So the way I'm going to do that is I'm going to say var p equals a new particle, and I just want to put it at the top in the middle, 300, 50. So I want to make a single new particle. Now, I'm calling the new particle constructor function. So over here, now what I need to do is I actually need to make something called a body. And body comes from bodies. So bodies is a thing that Matter.js will make. Matter is the physics engine. It's going to handle moving everything and doing all of that. So my particle object is just a wrapper for a Matter.js circle thing. So I want to make a Matter.js circle thing at x and y, and it needs to have a radius. This dot r. So, oh, but not this dot r. So I think that's right. So I should look in the documentation. I don't have Matter.js memorized, so I'm going to have to pull up the documentation here. Go under documentation, go under bodies, and now I'm looking for circle, x, y, radius. Now there's options and all sorts of other things which I might get into, but this looks like I'm doing well so far here. X, y, r. Okay, now the other thing I need to do is I need to say world.add world this.body. What's this doing? I have to, not only do I have to make a body, that's a matter body that can exist and have physics, I need to tell the world that I actually want that body to be in the world. It seems a little bit redundant, but you might want to make objects that you don't actually don't participate in the physics yet. So those two things are separated. And then I want to write a function where I can display it. And I should use, let's use the prototype thing. I have some videos that explain prototype. So let's throw caution to the wind. Prototype.show equals function. So if you're wondering about this prototype way of attaching methods to objects, I'll link to a video about prototype, but this is a way of saying all particles are going to have a show function. And in the show function, I'm going to say, what am I going to say? I'm going to say fill 255, stroke 255, ellipse. And where is the body? Now here's the thing. Normally when I make an object, I give it an x and a y or a position vector, but not here. Right now, I am relying on Matter.js to do all the physics for me. So it's up to me to say, hey, you know that body, that's a Matter.js body? Could you please tell me what its position is currently? And then I can say, and you know what I'm going to do? I know that eventually I'm going to want rotation. So I'm going to say translate this pos.x, pos.y, instead of setting the ellipse to that location. And then I'm going to draw the ellipse at 0, 0. And I want to give it a diameter, which is its own radius times 2. Now this .r doesn't actually exist. So I don't think that the, oops, and I've got an error there. I seem to remember looking at the Matter.js documentation that the circle body doesn't actually keep track of its radius in a property. So I'm just going to make an extra property myself to keep track of it, and that way I can draw it that way. So now I've made a body, I've added it to the world, and I showed I have my own particle object that is a wrapper for a Matter.js body, essentially. So now, whoops, if I go to sketch.js and I just say particles .push p, and then I say p.show. Let's see if it shows up. I hope so. I hope so. I hope so. I hope so. I would do my drum roll thing now, but that doesn't ever seem to work. Okay. Particle is not defined. I always forget to add the reference to the new JavaScript file. Yeah, and the sound was laggy. The new JavaScript file to the index.html. So I need to add that here. What did I call it? Particle.js. So I'm going to add that here. Okay, now I'm going to hit refresh. Okay, what did I miss? Cannot read property body of undefined at object. I must have done something wrong. Oh, I forgot to add the R. I added an R, and so it needs to have a radius. Otherwise, what's it going to do? Well, let's see if that fixes it. I'm guessing that fixed it. And now we're going to see the particle. There we go. So there's the particle, that single particle. Now it has no physics. Why does it have no physics? Well, here's the thing. A physics engine requires me to say, hey, go to the next moment in time. Move ahead in time. And time can mean a lot of different things, but it can mean real world time, it can mean frame of animation. In this case, I want to tie each time through the draw loop to a new moment in time. And the easiest way to do that, there's a lot of options, a way that you can configure this, is I'm just going to say Engine.update. I think that's all I say, Engine.update. Or maybe I have to say Engine.update. Well, let's try Engine.update. Does that do it? No, Engine.update is not a function. Engine.update engine. It might be that the function update is namespaced in engine, and then you pass in the thing you want to update. That's it. Okay, so you can see there's my Plinko particle falling down. So we're in good shape. We've got the Plinko particle. Now, maybe what I want to do also is just to kind of, is to do something like, let's have if frame count modulus 60 equals 0. So modulus is the remainder of division. So this will equal 0 when frame count is 0, 60, 120, 180, 240, 300, etc. So I'm going to say add a new particle every 60 frames, which is approximately 2 seconds. Let's do this. Show of undefined. Oh, right. And then, silly me, I should someday use a for each loop. But right now, I'm just going to loop through all the particles and show them. And here we go. So now we should see 2 seconds. And about 2 seconds later, oh boy, something must be wrong here. I'm not seeing any new. Where are those Plinko particles? If frame count modulus 60 equals 0, add a new one. That looks good to me. What have I done wrong? Let's console log frame count just to make sure that's a thing. Yeah, it looks like it's going. It started with 1, by the way. So I'm not sure why. What did I miss? Oh, I know what the problem is. You guys see it now? Look, it's right here. It's right here. Right there. Translate. Pos.x, pos.y. So I knew I meant to add this earlier when I was doing it, and I thought, whatever. So translations are cumulative. So when I translate to the position of one particle, the next particle I draw will be relative to that one. And so these are all getting translated way off the screen. I need to not have them be relative to each other. Rather, I need to say push, and I need to say pop. And now, so what push and pop does is it's like save, translate, restore. So it undoes the translation. And now, if I go back to my code, there we go. Look at all my Plinko things. Every 10 frames, my little Plinko particles falling down. So we can go back to Sketch, and I can take out this console log nonsense, and I can put it back to 60, and we can kind of, oh, and there's still another console log happening. Where's that other console log? Oh, particles.length. And so we can see here, and you know what? It's upsetting me that there's not one at the beginning. So I'm also going to, what I'm going to do is I'm going to write a function, new particle, that just does those 2 lines of code, and oops, and I'm going to say new particle here, and I'm also going to have a new particle instantaneously in setup at the very beginning. So now we get a particle, and 2 seconds later we get particle, and 2 seconds later we get particle. I'm a little bit behind. Okay, now the nice thing is the physics is already working, as you might have noticed when I made this. Like if I make this every 5 frames, you can see they're kind of like hitting each other. It's a little bit funny. That's a little bit like of a weird, but we're going to get to more physics later. Okay, now I think I'm going to do this as a 2-part challenge. So let me go a little bit further. Let me at least add the stationary Plinkos. So I want to now try to add these stationary Plinkos. And the truth of the matter is I could probably reuse this particle object and just make particle objects here and give them like an argument that sets them to static. But I'm going to make a seriously redundant code just for like sort of ease right now. And I could use inheritance in a nice way to have them relate. But I just want to make a separate object that just keeps track of these stationary Plinkos because I just want to treat them differently. So that's how I feel today. Okay, you can refactor my code later to make it better. Okay, so let's come back here and let's go to particle.js, and I'm going to do save as. This is really, I'm a little bit uncomfortable with what I'm doing here. I'm going to say Plinko.js, and I'm going to say function Plinko, and Plinko, I really should use inheritance here. We'll come back and use inheritance another time. Plinko.prototype.show, and something I'm going to do here is I'm going to add another variable called options. So when you create a physics object in Matter.js, in addition to giving it that circle body, an x, a y, and a radius, I can give it some options. And the option I want right now is static. Oh, and I'm editing the right file. Is static true. So, and then I want to pass this fourth argument as options. There might be a way that I could just make all these options actually. Could I make the x, y? I don't know if that's true. But anyway, that fourth argument is options. And there's other options I'm going to I'll add later, like friction and other physics settings. But let's leave that out for now. Okay, so now, and here's the thing. I could Matter.js also has these concept as a composite. So I could tell it to make a stack of things with rows and columns. So I could probably use that. Let's look at that for a second. Now, that's just not the kind of, I think that's great, but I feel like I just need to like set them in my own location right now without using the composite thing. So I'm going to say var Plinkos, and what I'm going to do is I'm going to say for var x equals, let's use I and j actually. I equals 0, I is less than, let's make the Plinko thing 10 by 10 maybe, or 10 by 5, I don't know. 5 by, I don't know what it should be. I should have some variables for maybe columns. Let's do that. And rows. And so we're going to have this many columns. And then I need a spacing. So I'm going to make a sort of a double loop here, nested loop, to go through all the rows. And probably rows should be on the outside, actually. Well, whatever. I'm not so sure just yet. Because I is the x. So actually, I think the way I'm going to think about this is to put I on the inner part of the loop. So I'm doing a nested loop, right? Because I want to say, set all of these. Then go down here and set all of these. So for every row, do all the columns. Next row, do all the columns. Or for every y, do all the x's. Okay, so now what I want to do is I want to say var p equals new Plinko at I times spacing, comma, j times spacing. Now, I haven't figured out what spacing should be, but I just want to know I don't want it to be at every column and row location with however far apart they're supposed to be. And let's just say right now, spacing equals the width of the window divided by the number of columns. So, because I need 5 across, and that's about the spacing. I'm sure I'm going to have to massage this a little bit. And then I'm going to say here, Plinkos.pushp. So now I'm adding the Plinkos. I love the word Plinko. It's such a great word. Plinko, Plinko, Plinko. Let's make a song about Plinkos. And now I want another loop here to go through all of the Plinkos and show them. And just to be 100% certain that they're different, I would like to give them like a different color or something. So let's make them like a green color. Color not being my strength here, but let's just do that. So what's going on now? Plink is not defined. So a lot of things first of all, I don't know where that happened. Where did I say plink? Plink is not as good of a word as Plinko. I much prefer the word Plinko. Oh, Plinko. And now I'm going to go to index.html. And now I need to remember this. I remembered it this time. I need to add a reference to Plinko. And now I'm going to refresh it. And what am I missing? Cannot read. I've got some sort of like thing that I forgot already again. I probably forgot the R again, right? I probably forgot to pass in a radius. I certainly did. So let's give each one of these things that's separated by spacing a radius of 4 pixels. And now I don't see anything. I see these things falling. I wonder if I have an I and J issue. I'm seeing they're called pegs. I'm being told in the chat by C-Manny that they're not called Plinkos, they're called pegs. That would be a good name for them. Okay, fine. The whole thing is Plinko. I times spacing, J times spacing, J is less than rows, columns, rows. This looks reasonable. Let's just look here. Let's look at the array. Let's make sure it's full of stuff. It only has one thing in it. That's a little bit weird. Oh, and look at it. It's all the way up there, which makes no sense whatsoever. So plus equals spacing in the for loop. Columns. No. Yeah, this is wrong. the whole point of doing this is I want to be able to think of the rows and columns as individual numbers, I and j, 0, 1, 2, 3, 4. And when I'm drawing it to the screen, I want to add the spacing aspect. So now we can see there they are. Now, it's not in any place that's logical. So one thing that I need is for the center column, right? I need an odd number of columns. Well, I don't need an odd number, but I need a column to line up with where the thing is falling. I need to have one of these columns in the center. So let me think about how to do that. And also, I want the particles to start at the top. Yes. So the particles starting at the top, and I need to make the whole thing much taller. So let's go down to 800 pixels. Great. So now we can see it's going down to 800 pixels. I want to shift everything down, right? Everything should start at, and I'm actually going to do this. Var x equals I plus 1 times spacing, because, no. X is fine at I times spacing, and y should be spacing plus I times spacing. Just to kind of offset everything by, and then I'm going to just put x and y here. This will make it a little easier to work out. Whoa, what did I do wrong there? Spacing plus a j, thank you very much. Okay, so that's a little bit better, but I also want to shift everything over by half of spacing, I think. So I want to shift everything over by spacing divided by 2. There we go. Ah, look at that. So, okay, so first of all, a couple things. It's pretty great, actually. Look at it just like get stuck and kind of roll over. So one thing is, this is definitely going to be a puzzle here of having working out the spacing. But one thing is, let's give these things some bounce. So the way that we give things bounce in Matter.js is by working with the friction and restitution. So restitution is a term for elasticity. A high restitution will make it very bouncy. And so what I want to do, and this is why I should be using, is I want to add this options thing both to particle and Plinko, which really should be a peg. And these are not static. I'm going to just work only in the particle for a second. Restitution, and I want that to be 1, which is as bouncy as possible. So let's just add that. Options. That didn't really seem to change anything, right? So let's get rid of any friction. So now the particles should have a high restitution and no friction. Yeah, that's a little bit better, right? You can see it's kind of bouncing, but I probably need to work on the pegs. I really do, the Plinkos, the pegs. So let's actually take these same variables. I'm not sure what it would do here to have sort of different amounts, but let's add a high restitution and a low friction also to the pegs. Wow, I really would expect this to be more bouncy with those numbers, but maybe it just hasn't gathered. Oh, I spelled restitution wrong. That's one of the things about JavaScript. It's not going to tell you. This is a really unfortunate thing. If I was working in another environment, it would be like, I don't know what that is. Restitution. Restitution. What's the chance I got that right now? Restitution. Boing. There we go. Boing. Boing, 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 boing. Oh, it's going to be fun to add sound effects to this. So, we can see now we've got something. We've got these things kind of bouncing along here. Now, they're all taking exactly the same path. How are we going to get it to have like a 50% chance of going, well, why is it going to the left? So interesting. This is super interesting. Okay, well, first of all, what I want to do is I want to shift every other row. So let's maybe reduce the restitution a little bit. Yeah, that's a little bit better. And then let me alternate where the rows are. So what I want to do is in the sketch.js, I want to say every other row, right, which is if j is the row, right? If j modulus 2 equals 0, then, so then let's, or equals 1. There's got to be a nicer way to do this. So I'm setting x. Then what I want to do is x minus equal, just sort of like take that. Let's do it this way. X equals I plus spacing. And then if it's an even row, then I'm going to add in, offset it by spacing divided by 2. Let's see if that works. There we go. So this looks a bit more. Now here's the thing. I probably need to really calibrate this in some way that they kind of, bounce. But let's not worry about that too much, and let's actually just make this. Let's just give ourselves a lot more columns and rows, and see what happens. And why is the top one now? Oh, because it's not even. I want to have 11 columns. Yeah, there we go. So, and I think I want, so there's going to be some, there's probably like a specific layout that's going to work pretty optimally well, but this is a good start. So this completes part 1 of this coding challenge. And what I'm going to do in part 2 is I'm going to do a couple things. I don't know what I mean. What am I going to do in part 2? I'm going to add buckets to the bottom to catch them and maybe think about the layout and spacing a little bit more. Okay? So that's what I'm going to do in part 2.